Welcome to this little video where I look at producing resin cast spare parts for my Thunder Tiger Mini Titan. I've recently got back into flying and I've got this lovely old model back out again. I got it about 13 years ago. It's obsolete. We're really going to struggle to get the spares that we need, particularly the ones that you're most likely to break because they're all sold out. And I've also got the UH1 and Cobra kits for it that mean this is just such a beautiful little aircraft. I'd looked originally at 3D printing, but I found the whole 3D printing a bit bewildering in terms of the choice of printers. I also wasn't sure that I could get a polymer which would give me the strength that I need for these parts, and it would also mean that I would have to CAD them as well. The advantage with resin casting is that if we've got the original part, which I have, we can produce a mould from that and then cast in resin, which should have the required mechanical properties, because these parts are going to be subjected to a lot of stress, a lot of vibration and a lot of wear and tear as well. Let's have a look at how I get on. I'm completely new to producing resin casting, so it's been a real steep learning curve. This is my third go on camera. And we'll start with Lego to produce the mould, and the advantage here is that we've got a consistent shape between the top and bottom halves of the mould. I'm going to be producing what's called a two-piece mould because the parts are too small and complex to do it as a single casting. Got a little bit of acetate along the bottom just to give us a flat base. We're going to use cling film in it to seal it up because the Lego bricks aren't liquid tight. I'm using new plast modelling clay, and I'm going to push this into the mould, and this is effectively a temporary bottom to the mould because we're doing two-part, and this is really at the moment just to hold the part in the right orientation to produce one half of the mould. So we'll just take the putty, we're going to squeeze it in, try and keep it as flat as we can, and then we get the part, and we need to be very careful and think a lot about the orientation of the part in terms of how the polymer is going to flow when we cast it. One trick that I learned is if you look at the original flash lines on the original part, which has probably been produced by injection moulding, that's usually a pretty good place to start in terms of thinking about where the part sits. So I pushed it into the clay in the right orientation. The next thing we're going to do is to add some keys, and what these will do is that they will orientate the top and bottom halves of the mould such that we get a nice tight fit and everything is totally lined up. I'm just using a brush handle to do this. We make them asymmetrical so that we can't get the two halves of the mould on the wrong way round. And because this particular part has a space, quite a large space in the middle, I'm going to add a little key in there as well. From there, we're going to think about adding the infill and outfill. So this is where the polymer is going to be pushed in. It'll then flow through the mould, and then it's going to go out through an outflow. So I'm just using a little bit of super glue, and I'm gluing on a little bit of doweling that's going to rise up through this cast bit of the mould here, and we'll have two of them on. More complex parts or bits that we've noticed air bubbles in, we would add additional infill and outfill. We've built up the layer of the mould round about it, and we're now ready to add some mould release agent. So this is Vaseline dissolved in a little bit of methylated spirits, or white spirit, the odour-free white spirit. Just painting it on. We don't really need to do it with the modelling clay. Certainly the experience I've gained so far is that generally the modelling clay and the silicone separate very well. I'm using CS25, which is a condensation cure silicone, 25 Shore, so it's relatively soft, but for very small intricate parts like this I think I need the lower viscosity silicone to make sure that we capture a lot of the details. We give it a really good mix. It's a 100:5 between the actual silicone and the curing agent, and we're then going to do what's called a thin pour. So the silicone container is, I'm standing and I'm dripping it onto the floor here, and what this should do is remove any bubbles in it. I don't have vacuum degassing at the moment to be able to do that. It's a bit of a messy job that I've done of it, but it does seem to do the trick. And the idea of the thin pour is that we've got a very, very thin stream, and that when we're doing the thin stream, that removes the air from the mould, and any little air bubbles that are in it, but again, particularly for little detailed parts like this, are going to cause big problems. So we need to be very careful about trying to eliminate air from it. We'll leave it 24 hours to set properly, and then we will dismantle the Lego from round about the mould to separate it. And it's one of the great things about Lego is that it's very easy to dismantle, and we can reassemble it again in exactly the same shape so that the two halves of the mould retain that same size and shape and orientation. And there we go, that's the clay bit of the mould and the silicone bit, which is the bit we really want to keep. So we'll just get the cling film off, get that separated off, and that allows us to then get in and remove the clay section of the mould. And once that's off, we will trim everything up just to get rid of some of that flashing. There we go, we'll just separate the two halves so they come apart very easily, which is what we want. And that will then show us the part on the inside that we are going to then reinsert back into the silicone half to produce the second half of the mould. But we'll need to do a little bit of trimming round about that mould there. There's some flash, there's some little bits and pieces that we are going to interfere with the flow of the polymer round about it. So we've trimmed this part of the mould up properly, part reinserted in the correct orientation. We've now got that half of the mould, a new bit of cling film, I've inserted it into the Lego. So this is the important bit now, is that we are going to make sure we really paint this up with mould release agent. So this is Vaseline dissolved to saturation in odour-free white spirit. And what that does, it leaves a very, very thin layer of Vaseline, and that means that we will be able to separate the two halves of the silicone. If we didn't have that on, when we pour the second mould in, it is going to stick solidly to it. So this is really important. And once we've painted it on, we'll do it a couple of times just to make sure we've got every last little bit. Then we're going to leave it to dry. We'll fill in the second part of the silicone mould. We don't need keys or infills or outfills on it this time, it's just pouring it in on top. Again, 24 hours to allow it to cure, and then we dismantle the mould, and hopefully now we've got the two separate halves of the mould that will be complete. So we'll just get out of the Lego, wonderful Lego, and we'll get the two halves of the mould separated and see what it looks like. There's the mould release agent doing its job, very easy to separate the two halves. The part will be a little bit stuck because we've got holes and things in there. The part is going to have little lines that are going to effectively attach it, so we'll need to get the part extricated from the mould and get this half of the mould all trimmed up, get some of the flashing and things removed from it as well. The bulk of the work is taken up in actually producing the mould, but that's not to say the casting bit of it is particularly straightforward. First thing we need to do before we start making the resin up is make sure the mould is ready. So we've got the two halves together, we've got an elastic band round about it to give it a little bit of pressure to hold the two halves together, and then we're going to start mixing the resins. I'm using Xencast P6, which is a toughened polyurethane resin. I'm using polyurethane rather than epoxy because polyurethane has a little bit of flex in it, which is what we need for these parts. I'm adding milled carbon and it's to 10% weight, which gives it quite a significant additional strength, which is what we need for these types of parts. There's an order that we do things in. The first is that we'll weigh the powder out, the carbon powder. We'll add part B, the correct amount of part B to that. We'll mix that well, because once we mix part A with part B, we've only got about 5 minutes working time, so we need to make sure everything is mixed and ready to go before we mix the two halves of the resin together. So that is part B pre-mixed with the filler. We're now adding that into part A, and the clock's ticking, so I'm going to stir this for about 60 to 90 seconds to make sure it's really, really well mixed, because that's really important. Make sure we get a good homogeneous mixture. Because these parts are so small, I can't really use a gravity feed to get the liquid to go into the infill and out the outfill. So I'm having to use a pressure fill, which is using a syringe, which is not ideal because it increases our risk of air bubbles, and also there's a risk that it will push the two halves of the mould together, because it's only light pressure we've got on the two halves of the mould. If we push the two halves apart, then we're going to get flashing. We're also going to get distorting in the part as well. So it's a fine line. I'm still learning, but this is what we're going to do. So that looks as though we're just about ready mixed. We're going to fill the syringe up. It's fine. We've got our mould that we're going to bring in. We're going to push it in as slowly as we can through the infill port until liquid comes out of the outfill, and that means that liquid's all the way through the mould in the inside. I'm then going to take the part and I'm going to sit it in a sonic bath for a couple of minutes, and what that hopefully does is it will minimise the amount of gassing and also improve the flow of the material within the internals of the mould. I'm doing a few parts. I'm doing a bit of a job lot here, that we've got about 5 moulds that we're doing. We've produced the polymer and we might as well make the best use of it. And then it's a case of leaving everything strictly alone for 6 hours to allow the polymer to properly set. So we've taken the elastic band off and some of the flashing off, and we're now ready to separate the two halves and see. It's the moment of truth, seeing what the part actually looks like. So we'll just gently separate the two halves of the mould. The material should be well set on the inside. There we go. And that looks pretty good. A little bit flashing round about it, but we can easily trim that off. And it's not a bad looking bit of kit. So you can see the flashing there. That's really because we've had to pressure fill it. That's obviously pushed out in between the two halves. We can see this is the advantage of the polyurethane. There's a little bit of flex in it, a little bit of give, and we get a part that really is very, very close to the strength properties of the original part. Because I'm learning, and because these parts are very small and they weren't using very much material, I made several parts during the process. And the ones that I'm going to test first in the aircraft are in the tail area, because we can test these with the aircraft running but not actually in the air. So if there is a failure on it, it's safely on the ground. The 3 parts that I'm using are the tail pitch control lever, which is a single part, and then there are 2 parts to the tail pitch control slider, and these are all involved in the pitch control of the tail rotor. And this is the movement they're involved in. Let's now run them up and give them some stress under load. Let's make some conclusions then. I think at this stage it shows a lot of potential. I have been able to generate some very small parts that are very close to the originals, both in terms of their shape, but also their strength and their flexibility. So the potential's certainly there. It seems to work for certain parts. There were a couple of parts which were thinner, which didn't really work. They were very brittle, and I think probably they could be remoulded by using putty to thicken them up so that they're effectively being re-engineered into thicker versions than the original part. And that's something I might look to. There's also variability between the various castings. I think I've obviously got a lot to learn about both the mould making side of things, which I think is really the area that there is most to learn with, but also the actual casting process. I think just because of the very small size of the parts, that I'm having to push the polymer through with a syringe, I think we're introducing air bubbles into the process, and that's providing weaknesses in certain area of certain of the castings randomly. So I'm going to have to test the strength of the parts by bending them in various directions before fitting them, because a lot of these parts, if they have a weakness in them, they're breaking very easily, whereas the ones that are okay last the sort of bending test, if you like. And that's probably due to air as a result of the actual process itself. Hopefully, as I learn, I'll find ways to produce the moulds that reduces the incidence of air in the actual casting process. But for my well-loved old Mini Titan, hopefully this now gives me the ability to actually prepare spare parts that are now being obsoleted, and certainly these tail parts that I've got fitted in the last video that we looked at there, they are now obsolete and you can't get them, and they are a bit of a high attrition part. The tail tends to get a bit of a smack every now and again if we land too hard. Hopefully that's been useful, and for those of you out there that are still flying the Mini Titan, hopefully this gives you some ideas as to ways that you can continue to fly this great little model. And thanks very much for watching.